Hi folks, welcome back to Physics with Captain Rod. I'm making this video to help you out with number 10. I believe this is Unit 2, third homework, number 10, I believe. So I picked this one to make kind of an in-depth video about because this one's, I think this problem really represents kind of the bulk of what it is I want you folks to learn about DC circuits. So before we even start talking about answering the questions, here are some things that I hope that you know about this point. One, I'm hoping that you could recognize constant potentials in this problem. And I'm going to go through and kind of color code the potentials here. The highest potential part of the circuit is here, right? And I usually color code high potentials in red. Nothing special about red relative to that. All right. But very important to realize that you are going to get potential drops across these resistors because the current's got to be forced through the resistors. So that's a constant potential. You're going to get a drop across those resistors, right? This is going to be some new potential. Let me do that more in an orange here. And then there's going to be a drop across this resistor. I'll do this one in yellow, all right? To this potential. And then there's going to be a drop across this resistor. So one of the things you should be able to do here, there's our lowest potential, is tell me how many different potentials there are in a problem. And here's what I mean by that. Let's say we define this one as 0. This would be analogous to setting a datum in a gravitational potential energy problem. Then the red potential here would be 25 volts because it's 25 volts higher. The orange would be some number lower than 25, but I don't know yet. We wouldn't be able to calculate that. And then the yellow would be some number lower than the orange, right? So we've got, I guess let's not count the 0, but the red potential, orange, and yellow, 3 other potentials above 0. The other thing you have to be able to do is you got to be able to tell me how many currents, right? So again, each branch gets its own current. So there's going to be a current here, a current here, a current here, and a current here. So there's 4 different currents. And one could even argue 5 because of here and here. Those don't necessarily even need to be drawn in, and I'll talk about why here in a minute. But so let me start putting these currents in. So the current in this branch, should be something like this. And then you give it a name, something like I1 or whatever you want to give it a name. You could call the current Bob for all I care. It doesn't really matter. And again, whatever I1 is, it's good anywhere in that branch, okay? Then we're going to get a current through this resistor. Let's call this one I2. And then we're going to get another current through this resistor, maybe I3, and another current through this resistor, I4. And again, I2, and again, pay attention to this. I2 would be good anywhere here. I3 would be good anywhere here. I4 is good anywhere here. Now, one could argue, all right, well, there's also a current here. And if you want to put one in there, go ahead. Let's call this one I5 and a current here. I6. If you want, I would accept that. If somebody said how many currents and somebody said 6, I mean, I would accept that. Notice here, though, if we kind of treat this like a system, going in is I5, out I6, it's not too unimaginative, I think, to realize these are the same currents. So let's just call this I5 again. Okay. Now here's the thing about these problems, though. Because I5 doesn't actually go through a resistor, it's not going to show up in any of the equations. There's nothing you need to really worry about. So anyway, now on to the problem. In this homework problem, I think R1, 2, these are all values that are known in the problem, although they're not in the picture. So I think what I would do is find the equivalent resistance. Add these 2 together. Then you would have 3 in parallel and get it down to this. You should be able to get it down pretty easily to a picture that looks like this. Whoops. Where this one's R1, here's our battery, 25 volts. This is, I'll say, R equivalent after doing the series, and the parallel combination. And then in this picture, we would have our current I1. You don't really have to go any further. Get I1. Just write a loop equation. Bang, get I1. Now, going back to the original diagram, you can now get any current you want. So let's say I wanted I2. And let me go back and state that a little bit more what I meant. You can get anything you want with just one equation, because watch what happens. If you write an equation for this loop, a voltage equation, the only unknown will be I2. You'll be able to get that. If you then write an equation for maybe this loop, the only unknown will be I3. I5 won't show up because there's no resistor. And I4 over here is not part of that loop. And then if you write maybe this loop, you can get I4. So that's how you can solve for the currents. And once you know all the currents, you know everything there is to know about the circuit. You can calculate powers, potentials, or whatever. Now, it's all about answering this question. Find the potential difference between A and B. So this is how I like to kind of work these. I mean, this one's a simple one. I mean, honestly, the answer is, you could do I2R will give you that potential difference. You can do this I3R here would also give you that potential difference. Those are a couple ways. But this is what I like to do. Let's say we're sitting here at A. We are at some voltage, and it is a number that we don't know, or nor do we really care, honestly. And now you just imagine walking over to B. So if I start at A and I walk over to B, you can take any path you want. Let me take the simple path. Right here, there's going to be an increase in potential by an amount I2R1. So equation-wise, we would put plus I2R1. And then we are to the red potential, so equals potential B. And then just move this over here. So potential B minus potential A, that's the difference in potential between them, is equal to I2R1. Now, the reason I went through this kind of longer description of how to do it is when there's quite a bit more in between A and B, you're going to want, trust me, you're going to want to do it this way. And I've already talked about how to get the potential through the 20 ohm resistor. So I'm just going to call that good. I hope that this video has helped you. Have a great day.